Welcome to today's tutorial where we'll explore one of the classic encryption techniques, the Vigenère Cipher. We'll implement it step by step in Java, and by the end of this video, you'll understand how it works and how to apply it in real-world situations. Before we dive into coding, let's get a brief overview of what the Vigenère Cipher is. The Vigenère Cipher is a method of encrypting alphabetic text by using a simple form of polyalphabetic substitution. In this technique, we use a keyword to shift the letters of the plaintext by different amounts. Let's look at how the Vigenère Cipher works. If our plaintext is a tachyton and our keyword is lemon, we repeat the keyword to match the length of the plaintext, resulting in lemon. Then we shift each letter of the plaintext by the corresponding letter of the keyword. To encode the letters, we find the corresponding alphabet position of both the plaintext letter and the keyword letter, add them, and then take the mod with respect to the alphabet length, which is 26. For instance, A and L would transform to L because 0A plus 11, L equals 11, which is L. Now, let's set up our Java project. Open your IDE and create a new Java project called Vigenère Cipher. Next, let's create a new class named Vigenère Cipher. This class will contain the methods to encrypt and decrypt our messages. Now, we should implement the encryption method. We'll create a method named encrypt. This method will take the plaintext and the keyword as parameters and will return the encrypted message. Inside the encrypt method, we loop through each character of the plaintext. If it's a letter, we calculate the corresponding letter in the keyword and apply the shift. If it's not a letter, we simply append it to the ciphertext. Next up, we need the getShift method. This method will compute the shift based on the keyword character. We'll only care about uppercase letters for our keyword. The getShift method calculates the difference between the keyword character and a, which gives us the necessary shift value. Now, let's move on to implementing the decryption method. This will be very similar to the encryption method, but we'll subtract the shift instead of adding it. In the decrypt method, we again check if the character is a letter. If it is, we compute the decrypted character by subtracting the shift and ensuring we wrap around correctly using the modulus operation. Now that we have our encryption and decryption methods, it's time to test our cipher. Let's implement a main method to demonstrate both functionalities. We will create an instance of our Vigenère Cipher class and call our methods with sample input. Running this code should give us the encrypted and decrypted strings printed to the console. This will allow us to verify that our implementation is correct. Let's quickly run our main method and take a look at the results. If everything has been implemented correctly, you should see the encrypted text first followed by the decrypted text. Now we will provide some examples and additional explanations to deepen your understanding. Let's take another plaintext, say hello world, with the keyword key. We will manually compute the expected output so you have a clear understanding of what should happen. For the plaintext, hello world, and the keyword key, we first repeat the keyword key. Then for the first letter H, 7th position, and K, 10th position, we get 7 plus 10, mod 26 is equal to 17, which corresponds to R. Following this process for each letter should yield RIGVJN. Let's check it out in the code. Now let's include this example into our main method to see how it runs. Once executed, you should see both the encrypted and decrypted outputs in the console. If your outputs match the expected results, congratulations! You've successfully implemented the Vigenère Cipher in Java. To further enhance our implementation, let's handle edge cases such as non-alphabetic characters in the plaintext or keyword. We can add a validation method that checks whether both strings contain only alphabetic characters. With this validation check in place, we can modify both the encrypt and decrypt methods to use this check before proceeding with encryption or decryption. Now we can handle cases where the user inputs invalid characters more gracefully by alerting them with an error message. In summary, we started by understanding the Vigenère Cipher and its encryption mechanism. Then we implemented the ciphers in Java, created methods for encryption and decryption, and improved the implementation by adding input validation. This illustrates good practices by ensuring the integrity of input data. As a review, you can see how we modularized the code into methods, which allows for easier testing and reusability. If you enjoy cryptography and want to expand your knowledge, Consider learning about other ciphers like the Caesar cipher or check out modern cryptographic methods. Thank you for joining me in this video tutorial. If you found it helpful, please give this video a thumbs up, subscribe to the channel for more tutorials, and leave a comment if you have any questions or suggestions for future topics. Happy coding!